Hello friends, welcome to yet another video tutorial with Khan the Elucidator, and today we'll look at the process of centrifugation. So we're actually looking at the principles of centrifugation. So if you have already subscribed to this channel, please hit the notification bell to get first-hand notifications, because it is really a challenge for me to record, post, and then start notifying people that have posted something. Better you subscribe, you hit the notification bell, and you just relax and wait for the videos and notifications whenever I post them. So we can get straight into the principles of centrifugation. But before I start talking about centrifugation, I would first love us to understand what sedimentation is. Sedimentation is. What is sedimentation? So to define sedimentation is simply the tendency of letting particles in a liquid suspension settle with the application of a gravitational force, which is natural. It is natural gravitational force that causes sedimentation, or particles to settle down naturally. Think of a mixture of sand and water. You mix sand and water, then you just put them there to settle. After an hour or two, you will notice that the sand particles, which are solid, will settle at the bottom, and then you have the liquid part, which is the water, just on top, and that is called sedimentation. But remember, this, I mentioned something like after an hour or two, so this takes a long time. It consumes time, so we need these types of separations to be faster than this. So this is where centrifugation as a whole come in. So centrifugation comes in because it applies an induced gravitational field to these liquid suspensions. So to define centrifugation, we can say centrifugation is a technique used to separate components in a liquid suspension with the application of a centrifugal force. So you apply a centrifugal force which applies an induced gravitational force that causes particles to settle at a very fast rate. Exactly. So now what it is that separation in this centrifugation process is based on SSD of the particle, which is size, shape, and density of the particle, and it also depends on viscosity of the medium, and also it also depends on the rotor speed. So viscosity is simply how thick the medium you are using, the liquid medium you are using, and rotor speed we'll be able to understand when we look at the types of rotors and what they do. So I talked of something like centrifugation involves the application of a centrifugal force. So what is a centrifugal force? What is centrifugal force? So to define centrifugal force, we would say it is an outward frictitious force that is subjected on an object which is moving in a circular path, and it is directed outward from the center of rotation. So if this is an object moving in a circular path and this is the axis of rotation, centrifugal force is directed outwards from the center of rotation. That is the centrifugal force right there. And centrifugal force is opposed by two forces, namely the buoyant force and frictional force. So buoyant force, I wouldn't want to start defining it and everything, but I would just mention that it is the force that keeps particles from sinking. it causes them to float. That's a buoyant force. And frictional force, we know what frictional force, it just acts in the opposite direction of the forward force. That's frictional force. So these two forces oppose the centrifugal force. So in centrifugation, when particles are subjected to centrifugation and a centrifugal force is applied, when the centrifugal force exceeds these two forces, the buoyant and frictional force, then particles will finally sediment or they'll settle. So you have those particles which here will define as the heavier phase, or the larger particles or the denser ones, they'll settle at the bottom as pellets. They'll settle at the bottom as pellets. And you have the lighter liquid phase or any lighter phase. If the solids are lighter, you'll find them on top as the supernatants. So that's how it is. When the centrifugal force exceeds these two forces, then you have particles settling down there. They'll be denser than the lighter ones, and they'll settle there. If the buoyant and frictional force is greater than the centrifugal force, then you have particles failing to sediment, and that's what happens to the lighter particles or the supernatant that doesn't sink to the bottom but rather remains on top there. So this is a basic quick introduction on the centrifugation process. So this same centrifugation process is carried out using an instrument known as a centrifuge. So you can define a centrifuge using the definition of centrifugation. Just say it is an instrument or machine or device used to separate components in a liquid suspension with the application of a centrifugal force, and that would be correct. So this centrifuge has three components. It has 1, a rotor, 2, a motor, and 3, a drive shaft. But rotor is the most important. Please don't forget what a rotor is after defining it. It will define it as it's the one that holds the tubes. It holds the tubes or bottles which are to be subjected for centrifugation process. And then this same rotor is mounted to a drive shaft which is connected to a motor, and the motor supplies power for the centrifuge to spin or the centrifugation process to take place. But rotor, again I insist, don't forget what a rotor is, because it may prove to be very, very helpful if you understand what a rotor is. So now, after looking at what a rotor is and everything, we can look at two basic formulas that we should always remember in this centrifugation process. But if there will be time, I would love us to look at these formulas in detail and look at how they are derived and everything, so that we get the basic concept. So we can look at centrifugal force. Centrifugal force has centrifugal field has the formula m omega 2 or omega squared r, and in biomedical science the centrifugal force is mostly referred to as RCF, which is the relative centrifugal force, and the formula of finding this is 1.12 times 10 to the power negative 5 rpm squared times r outside. So these are the basic formulas that you can use to find the relative centrifugal force and the centrifugal field itself. but I would love to make a video tutorial and explain how we can derive these formulas and maybe look at one or two calculations and yeah, maybe try and help each other. So another thing, the second part I would love us to look at is the types of rotors. I talked about rotors, that a centrifuge has a rotor, a drive shaft, and a motor. Then I talked of rotor being very important. So these rotors can be of different types that can be mounted to a drive shaft. So we have different types of rotors, but three basic types are one, the fixed angle rotor. Fixed angle rotor is the first one. And what we should know on this is that in this type of rotor, tubes are held at a 40 degrees, are held at 14 to 40 degrees angle to the vertical axis of rotation. So tubes are held at an angle of 14 to 40 degrees to the vertical axis. So how it actually looks is this. You have the vertical axis there, and these rotors are like that. They hold tubes like that at an angle. They're not straight, but they're like that. So you have particles being suspended in such a way. So these are fixed angle rotors that hold tubes in this type of way. So in these types of rotors, what you should know is that separation takes a short period of time because particles tend to move a very short distance with this way of arrangement. So particles move a short distance, and this leads to separation or the centrifugation process being a short one. It doesn't take a lot of time. So basically, that's what we can know. And these types of rotors are mostly used in differential centrifugation. Two, we have vertical tubes, vertical tube rotors. So the vertical tube rotors are held vertically parallel to the rotor axis. So how these vertical tube rotors look is like this. So you have this being the axis and holding the tubes just vertically parallel to the rotor axis. And just like in the fixed angle rotors, particles move a short distance in here, and the separation takes a short period of time. But the limitation in using vertical tube rotors is that just after performing the centrifugation process, since tubes are held like this, there is a possibility of the supernatant and the pellet again remixing after stopping the centrifuge. Unlike in here, you have the supernatant settling like that, and possibilities of the supernatant and or the pellet and the supernatant remixing are slim. But in vertical tube rotors, it is possible for the supernatant and the pellet to remix after stopping the centrifuge. So there are limitations, and it is not favorable to use this type of rotor. Then we have the third type of rotor, which is a swinging bucket. Swinging bucket rotor. So with the swinging bucket rotors, what happens is that initially, before the centrifugation process starts, they are held at a vertical position. But when acceleration starts, what happens is that they swing out. The tubes swing out and they become horizontal to the rotor axis. They swing out, they lay like that. And what happens is that we know that the centrifugal force here is like that, here it's like that, and in here it will be parallel to the tube. The centrifugal force will be parallel to the tube. And in this type of setup, there is accuracy in separation. Why? Because particles move a long distance. Particles move a long distance in this type of setting, and it takes a lot of time. So there is accuracy. There is a accuracy. So these are the three basic type of rotors that you have to remember: fixed angle, vertical tube, and swinging bucket. So just after understanding that, we can now look at the third part, which is the types of centrifuges. So types of centrifuges, there are many types, but depending on speeds, we can classify them into 3 or 4 types. But in here, I'm going to just highlight the 3 main types of centrifuges, which are: 1, the low speed centrifuge. It is the low speed centrifuge. Then there's high speed and ultra centrifuge. But we can start with the low speed. So 1 is the low speed centrifuge. So with the low speed centrifuge, what we have to understand here is that this type of centrifuge uses a speed range of 1 to 6,000 RPM. So it uses the speed of that ranges from 1 to 6,000 RPM, and it has RCF value up to 6,000 G. RCF value up to 6,000 G. And this same low speed centrifuge is an instrument that operates at room temperature. It operates at room temperature, and due to low speeds, there is little or no heat generated on during the process. So temperature control is not necessary. That's why it can be operated at room temperature. Why? Because it has low speed and it does not generate heat when the process is taking place. That is why it is the most used in standard labs. So most used in standard labs. So you find it there at your laboratory, at your school lab. You'll find that this is the most used. And the types of rotors used in this type of centrifuge, the low speed centrifuge, we have 2 types of rotors. Remember, 2 types of rotors: fixed angle and the swinging bucket. 2 types, don't forget. The fixed angle and swinging bucket are used in the low speed centrifuges. Then the second one is the high speed centrifuge. High speed centrifuge. In this type of centrifuge, basically what we can talk about is that it uses a speed range of about 10,000 to 25,000 RPM. And 2 is that it can even acquire an RCF value up to 50,000 G. 50,000 G. Then another thing is that unlike in the low speed, high speed, due to higher speeds of spinning or centrifugation process, heat is generated. Heat is generated. So mostly what happens is that temperature is maintained at 4 degrees Celsius. Temperature is maintained at 4 degrees Celsius. Why? To preserve the biological samples from getting damaged. If you're looking at proteins, you would even look at denaturation of proteins. So to prevent that, temperature is maintained at 4 degrees because heat is generated due to speed, high speed, not speed but high speed. And last but not the least, types of rotors used in high centrifuge are all types. All types of rotors can be used. The third type of centrifuge is the ultra centrifuge. So ultra, we know what it means. Ultra means it has unlimited speed. Let's not say unlimited, but let's just say very, very, very high speed. And this type of centrifuge is the most sophisticated. Or we can say it is the most advanced, most complex, most developed, but yes, it is the most advanced or most complex centrifuge. One, it uses very high speed compared to these two others. It uses very, very, very high speed, and because it uses very, very high speed, intense amounts of heat is produced. So intense amount of heat is produced in this type of centrifugation or centrifuge, and due to that, an internal rotor chamber refrigeration system is mounted in such a centrifuge. Why? To keep or to maintain low temperature. So there is refrigeration in the rotor chambers to maintain low speed and everything. But the goodness is that all types of rotors can be used. The swinging bucket, the fixed angle, and the vertical tube can be used. And an advantageous point is that an ultracentrifuge can even isolate much smaller substances such as ribosomes, proteins, and viruses. Unlike these other centrifuges, this can isolate much smaller particles due to the high speed that particles are subjected to in the ultra centrifuge. And just a little bit of history, just for you to understand. In 1920, Theodore Svedberg, or you can say Svedberg, mounted the first analytical ultracentrifuge or an analytical centrifuge. So Svedberg in 1920 mounted the first analytical centrifuge. That's the history right there that you can know. If you want more information on that, you can search, because it is quite complex, it is quite large, but that's just that. And just by saying this, we can say the basic principles of centrifugation have been elucidated. So the next part that we have to look at is basically the categories of centrifugation, and this we'll see or we'll watch in the next tutorial that is coming soon. So please stay tuned to my channel. If you enjoyed this introduction, please subscribe or like it, and if you haven't subscribed, please subscribe to my channel so that we keep these videos and everything going, because your subscriptions and your likes and your views show that we are really going somewhere, and we'll continue helping each other until the end of time. So thank you. It has been a pleasure elucidating to friends like you. Enjoy the video and see you next time.